All right. Waiting for the latency. Did I hit live? I did hit live. All right. Looks like we are good to go. Good morning, everybody. There we go. Okay, yes. Audio is good. Just checking everything and making sure that everything is good to go because this is a little earlier than I usually stream. Ugh. Excuse me. I've got morning voice. No, that's not true. I stream it this time on Wednesdays, but on Fridays I usually stream at 4, and this morning I'm streaming at 9. That's AM my time, so it's morning for me. That's just a little difference of things. So, hi Haja, welcome. Today we're going to be continuing our code review. So last week we did a code review of an R project that was doing sentiment analysis on Twitter data around the Indian state level elections in a specific state. And today we are going to be looking at Python, and this particular analysis is looking at imbalanced data. Look from a data set that is looking at churn and a telecom. So let's look at the data set really quickly, sort of get a sense of the structure of this project. So the file is called bigml_, blah, 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 .csv, so that's a great start. No, I'm sure it'll be fine. So we've got states, and these are American states. That's West Virginia, that's Montana. Account length, and does it say what units these are in? It does not. Let's see. Yeah, it doesn't say what units those are in. So I'm guessing that those are maybe days, how old the account is. Then we have area code, and there's just a bunch of different area codes. And then we have phone number. And then we have whether or not this particular plan includes the ability to make calls internationally or just inside the United States. And then let's scroll down a little bit so I get my sideways scroll bar. Shmeep. Actually, you know what? A better way to look at this would be using this view. There we go. Area code, phone number, international plan, whether or not they have voicemail if they're paying for that. So this strikes me as sort of an older data set, probably. It looks like it's covering the number of minutes, and at least in the US, some phone plans are on a minute-based rate, but it tends to be a little less common. So I guess it used to be that you would pay for each minute that you were calling, and then these days it's more common that you have like X minute of calls. But I never call anybody with my voice because I'm a millennial, so I'm not keeping super close track of that. Number of voicemail messages, the total daily charge, and it looks like this distribution matches the distribution of total daily calls and total daily minutes. So it looks like they are charging per minute or per call, maybe. Total evening. Oh, that's right. You used to have to like pay more to call people in the evening. I remember that from the 90s. Evening minutes, evening calls, evening charge, at night. International customer service. So presumably this is customer service for the telecom itself, which usually you don't get charged for, or at least used not to be. Hi, Kumar. And then there's churn. So churn is whether or not someone has stopped using a specific product. So on Kaggle, we might say, well, I guess you don't pay for Kaggle. Like Netflix. So if somebody canceled their Netflix account, the number of people that cancel their Netflix accounts out of everybody who has a Netflix account would be the amount of churn, right? And you don't, if you're running a business or providing a service, you don't want people to stop using your service that they're paying you for, because then you lose money. And it's almost always harder, and this is sort of like business wisdom, it's harder to get a new customer than it is to keep an existing customer. So you want to minimize churn. That's the whole business justification here. And I'm wondering if we can find out a little bit more about this particular data set. Let's see. So there's no like description of what's in the data set here. There are some kernels, there's no discussions. No one's been chit-chatting. It's pretty popular, specifically in India. So this looks like it might be something that is used in a course, perhaps, that people might have used it. Ryan says, wait, we're not supposed to be paying for Kaggle? If somebody is charging you money and saying that it's from Kaggle and you are not currently running a competition through us, you should get your money back. You are being scammed. The Kaggle website we don't charge y'all for. We do charge if you want to post on our job board, which is here we are. So the people who post here because they want to hire data scientists do pay us, and then people who host competitions, companies that host competitions also pay us for that. But yes, you as just like a Kaggler should not be being charged. Okay, so it looks like there's not a lot of in-depth description of how this data set was collected. Has David Bex done anything else? No. Nope. Looks like not. So it looks like this is just sort of a data set that's provided as a way for you to look at churn. I'm guessing that these phone numbers are maybe generated, so maybe the area code is right, and then the phone numbers they sort of made up. I don't know that for sure. And it does look like this might be a little bit of an older data set, but again, we just don't have that information. So, all right, so we don't know a whole lot about the business. Or I don't even know that it's a business's data. It could very well be just generated data that's not actually from a specific business. All right. Oh, is there any other metadata? Unknown license. So you wouldn't want to use this for any sort of business use case because you wouldn't have the rights to do that. Probably, it's hard to say. Last updated in 2017, and this is version 1. Good morning, we're all on you. Okay, so we don't have a lot of information about the business use case here. So presumably we're going to have to do a lot of inference about what it is that is useful. Something that's new is these little headers. And it looks to me at the moment... Okay, so that sent us to the middle of the page rather than where the table of contents heading is. So I might need to check in with the folks that are working on that. All right, so we've got, and then do these work? Yeah, those work. Okay, so these links to different places in the kernel work. Kurian says, how easy it is to host a challenge in Kaggle? I am learning more about the system architecture of how submissions are processed in Kaggle. So anybody can host a competition using in-class. So then you just sort of upload the thing that you want to do and you can just run it yourself. If you're working with us to host a competition, we obviously have a lot of experience running competitions. We want to make sure, we want to minimize leakage and make sure that you're asking a question that's sufficiently complex that everyone's not just at ceiling immediately. So it really depends. And if you're interested in hosting a competition, I would reach out to the competitions theme through hosting a competition. Swamos says, I like this time of day to stream. Okay, that's good to know. I'll probably run a poll at some point on YouTube or on Twitter, just trying to get a feeling of when is best for people. Because I know I've got a global audience, which is fantastic, but it does make it a little bit rough finding a time that works for everybody. All right. So let's jump into this. The first thing that I see right off the bat is this is a big notebook. So we've got 6 sections. We've got a bunch of different subsections. It is organized, so I really like that. I like having these markdown headers so that I can go back and forth a little bit more easily. This is probably more information than I would give to if I'm doing this analysis as part of a project for a company, this might be my first stage. So this would be like the work that I would do for myself. But if I was handing it to a stakeholder, I'd probably pick maybe at most 2 different methods and be like, here's the methods I looked at. These were the top performing 2. Here's the trade-off of each. This is a lot to give somebody without much of a data science background. This is a lot of sort of like math and code for them to look at. So that's my first piece of feedback, and it just depends on who your audience is for the analysis that you're doing, and that's going to depend on your specific business use case and where you're working and all that. Okay, so it's an analysis of this data set that we looked at, and it looks like, okay, so number of days. So we have information here on the data set that is not mentioned in the data set itself, so I don't know if this data set is being used like in addition to other material in other places. It's me says, when will CareerCon 2019 videos be uploaded? I don't know. I'm not really involved in that. I'm sorry. I'll ping the team though that is working on it and be like, hey, folks are asking for it, which they know. They know people are looking into it, but there's some like editing and stuff, and editing takes a long time, which is why I never do it. Okay. So this might be a data set that's being distributed with more information in like a face-to-face setting. So people are like, here's the link, and then here's more information that I have. Or maybe this person. So this analysis is by Alexander Abstrutier? Abstrutier? I don't know. Could be French. Hard to say. Okay. So this might be, so I'd call this like a data dictionary, and this might be useful if you're working, again, in a team, and this is maybe information on a database that everybody on the team is using. This could be even a standalone document, maybe. It's pretty common in like government use cases to actually distribute the data dictionary as a PDF. So a lot of like census data and a lot of like World Bank data will have the data dictionary as a PDF. So just, I don't know how relevant that is, but that's just like a thing that is true about some data sets that you might run into. Loss of customers or clients, yep. Can effectively focus a customer retention marketing program, e.g. special offer. So it looks like they're trying to identify Okay. So the stated business use case here is to identify customers that are likely to leave so that you can reach out to them before they leave. So customer retention, to retain is to keep. I don't know. Okay, so here's the thing that I am worried that we're not actually going to get with this particular data set. So this data set doesn't have information on when the people left. So we can sort of see, how long people have their accounts before they close them. We can see sort of like if specific area codes, people are more likely to close their accounts, things like that. We don't necessarily know what factors precede somebody closing their account. So we only see whether the account is closed or not. We don't see changes in behavior over time before somebody closes their account. So something that we would want to watch out for in this particular analysis is that we're not just like, these are the people who are is that we're not identifying factors that are like, these are the people that we're absolutely going to lose no matter what. Because if you try to maintain those customers, you're going to have a really hard time because they're not going to keep their account. So maybe there's like a free trial period and they use it for the trial period and then immediately cancel their account. The thing that I think is harder to find out, but would be probably more useful in the long run, would be who is likely to close their account soon. So identifying which customers in here are on the verge of canceling their account, which is really hard to figure out from the data. You might have to do some customer surveys to identify that. So what we'll be able to figure out with this data set is what qualities correlate with people who have left. And we can target those people with our customer retention attempts, but we can't identify people who are thinking about leaving without more data and more information. So that's sort of my caveat there. Data Nerd says, how do I get domain knowledge about a particular industry like telecom insurance? That's really going to depend on the industry. I would say probably the most effective way for me personally to build an understanding about a specific industry is to have informational interviews with people from that industry. So it's fairly common in the US to reach out to somebody, especially if you know they're a friend of a friend or they're in the same city that you are in, and be like, hey, can I take you out to coffee and pick your brain about maybe they work in like fleet management. Pick your brain about fleet management so that I can know more about it. Maybe you've applied to a job or you're looking to apply to a job in a company in that particular industry and you sort of want to get a better idea. So taking somebody out for coffee, sitting down, asking them to sort of like explain the state of the art and what's important and things that might not be super obvious to an outsider is what I have done in the past. But your mileage may vary. You can always read blog posts, and a lot of industries will have industry-specific publications, or like magazines that are like, you know, for truckers. And if you're interested in learning about trucking, you can read the trucker magazines and you'll get more information than you had previously, probably, unless you are currently a trucker. All right. Anyway, so that's just sort of thinking about the business problem, which is often the hardest part of any given data science project, is making sure that the problem you're trying to solve, the thing that you're looking at with the data, isn't just the thing that's easy to get from the data, it's the thing that you actually want to change. Varun says, data from people survey will give their insight only. How can we predict customers who didn't respond to the survey are on the verge of leaving? That's really hard. Yeah, fancy math is basically the answer there. And I don't want to get too much on like what I would do. I want to see what this particular person did. And Prithviraj says, can churn be predicted as a time to event? Yeah, I would probably... So my particular preference for this type of analysis would be to identify customers and sort of bin them. So like high risk of leaving, medium risk of leaving, low risk of leaving, because there's always going to be a span and you don't know what's going on in people's lives. And you shouldn't as a data scientist. We don't need that much information. So being able to sort of like identify the group that is at most high risk of leaving within, you know, a certain certainty would probably be my end goal. All right. The analysis was conducted in Python 3.7.0 using Jupyter Notebook, which is a web application that that allows you to create interactive environment that contains live code, visualizations, and text. In addition, the following packages are used: Pandas, NumPy, scikit-learn, imbalanced learn, provides a number of resampling techniques commonly used in datasets showing strong between class and balance. So if everybody stops using our service, we want to, make sure that we have good examples of people who keep using our service so we can understand that population. And then Plotly. Okay, this is something that I probably wouldn't include in something that I gave to somebody else. This feels a little bit like coursework, which is not bad. I'm just like, this is not information I would hand to my colleague, unless maybe they don't work in Python and I work in Python extensively, and I want them to know about the specific libraries that I'm using. Okay. So we've imported... Okay, so some things we're importing wholesale and aliasing, very common. Other things we're importing specific parts of. That makes sense. I almost never import all of scikit-learn. It's just big and you don't use all of it. I'd probably tidy this up. So it looks like at some point FastICA was imported and then the author changed their mind. So I'd probably just get rid of that. We're... SVM, linear models, neighbors, metrics. Okay, this all seems pretty reasonable. And it is a lot of imports because there's a lot of things happening in this notebook. And then from imbalanced, and then plot libraries. So this is actually only one plotting library. This is stuff from Plotly. And I probably wouldn't import just Plotly unless you need things in the top level domain space, because we are also importing other things from it. And then, okay, we've got some more things that were imported and then we've removed. And it looks like this is in part to protect credentials, because Poly you can pay for. So I'd probably move this import up here. And this is more style stuff. This is not super important. Ignore warnings, okay? Specify seed, and then when you plot out a data frame, make sure that you can see all the columns and scroll back and forth instead of having first few columns, ... last few columns. These I probably wouldn't put in the same cell as import, just because they're sort of a different thing. But if you're interested in that, I think that's fine. Okay, and Kumar says, in business use case, where we have use cases like this to identify customer behavior leading to churn, what approach we should take to identify the data needed to be collected, and do we have the right data? That's super going to depend on your particular use case. I mean, I would talk with stakeholders. I would, like if there's a product manager for the product, I talk to the product manager, get some idea of things that they think might be important. If we've done previous customer surveying, I'd look into those. If there's any sort of happiness and tracking survey that's been going out, I'd look at that data. Collecting data tends to be very slow and expensive, so I would first try to use the data that I already had and search for it from a lot of different sources. Because oftentimes you'll have people at different places in a company who have data sets that they've collected and used for whatever, maybe like a presentation or something, that probably don't have like confidential user information in them, but just have useful information that you could use, and going around and talking to people and being like, hey, do you have anything that's relevant to this that I could use, or do you know of anything, or has anyone been using this? So that's just sort of what I would do. And then if you're interested in data collection yourself, I would read up on experimental design, particularly from psychology, and survey design as well, because that will really affect the data that you get out. Okay, and here we've got, I don't love the uppercase variable names, just because for me they're a little bit harder to read. I don't mind that they're that they've got underscores. That's fine for me. It doesn't, I think, and it'll depend of course on the style guide for the specific place we write code, but I think the guidance is lowercase in variable names except for classes, and then the first word should be uppercase. This feels a little bit Fortran-y to me almost. And again, I just find higher uppercase things harder to read, and I am dyslexic. So, and we've got some dictionaries here with the keys being different features that we're going to use in our models later on, and then the values being possible values for these features. So this looks like it's going to be something that we'll use for model comparison later on. So we might use this for like grid search or something. I don't think this is necessarily a bad way to do this. It feels a little bit odd for me, and I'm not very deep in the Python community. Like I use Python and I read Python code, but perhaps there is a community where this is super common and this is sort of the normal way that people do things, and I would definitely follow the established conventions in whatever you're doing. And I do like having all of the parameters defined at the top. Again, if I was going to hand this to somebody else in my company, I would probably be like, and these are the parameters that I've picked, instead of having this sort of various options, grid search sort of style. Ekar says, aren't the uppercase for constants? And Martin says, all uppercase variables are usually reserved for setting global variables. Okay, that makes sense. I guess these are global within the notebook. I don't know. I haven't seen parameters. I don't think this is wrong. I think it's very logical. I just haven't seen this before, so it took me a second. And I'm wondering if we're going to do all the combinations, and something that. So one possible drawback of using this particular method is if it turns out maybe you have a very complex data set. So max depth is one of those things where I'm pretty sure max depth is one of the features in random forests that has sort of like an asymptotic effect on your particular your model performance. So if you just sort of increase it, you'll get better and better and better over time, but your improvement for each increase will get smaller over time. And at some point you'll start overfitting, as opposed to features that have sort of a, I'm trying to keep it in here, parabolic relationship to your model performance, where there's a sweet spot and you want to be in the sweet spot. So my worry here is that we might end up underfitting if the range that's ideal for our specific modeling problem is over here, or we might end up overfitting if the range that's best for our specific problem is up here. So like if 10 would be is sort of like the sweet spot in our elbow, we'll miss that, and if like 80 is the sweet spot in our elbow, we'll also miss that. So that's, I don't know how these values were picked, but that's something that could be a possible drawback to this particular way of doing it. All right. And then we've got some dataset exploration. So we're reading it in. We've got 3,333 rows and 21 columns. I'd probably use F strings here just because I like F strings, but this is perfectly fine. Search for null values. So there are no null missing values in the data set. And this is very nice and human readable. If I'm handing this to a data scientist, I don't know that I'd need to print these as statements. I could just do like, show me the dimensions, and I, like as someone who's worked with pandas a lot, I'd be able to get the information out of there pretty quickly. But this is nice. I guess if you're expecting somebody else to also do some data exploration who's not as comfortable with Python, that could be useful. And then we look at the head and we see all the columns because we've set the column height to all of it. And then there's sort of a text description. Phone number column is removed because each customer has its own phone number. So that would be a good way. So phone number... where am I going with this? That's a great way to do leakage, because if you predict whether or not someone's going to stop being a customer based on their phone number, you'll have perfect accuracy because you know the phone number of everybody that quit. And you don't necessarily know when you have a new phone number if that person is going to quit or not. So that's definitely a good thing to remove in this case. Using label encoder for the state, which replaces each unique label with unique integer. I think that is okay. You want to make sure that you are treating integers. You want to make sure that you don't say that like Arkansas is the number, or whatever would be the first, probably Alabama. You don't want to say like Alabama is number 1 and it is, and that like Arkansas is 2 more than Alabama. So when you are encoding, categories with numeric variables, that's something that's important to watch out for. PCA might do that. Okay, so this might potentially be a problem later on with other models. My intuition is that state is not going to be important as things like, well, actually, you don't need both state and area code because they're sort of redundant. They both give you geographical information. So I would probably use area code over state, or I would use state to get me sort of larger geographic information. So I might use sort of like politically and socially relevant geographic areas in the US, so like the West or the Northeast or the South, which is the Southeast, or the Upper Midwest, or categorizations like that, that I think people in those areas might tend to have behavior that patterns together for specific ways. David says, would it be better to use get dummies to treat them like categories? I'm not super familiar with get dummies, but that sounds right to me. Churn problem is a binary classification problem, so can the techniques used here be used for multi-class classification? Yeah, they should be. You would need to change the So instead of like logistic regression, you'd probably want to do, instead of binary logistic regression, you'd want to do multi-class logistic regression. Wow. One sec. Sip of coffee. JR says, Git Dummies is a pandas version of one hot encoding. Oh, yeah. You would end up with a lot more features then. So that's something to watch out for, because you'd get 50 features because there's 50 states in the US, assuming that you have representation from every state, which is part of the reason why I bin the states into relevant groups. And this is just what I would do. And you could do multiple things and see what works. Phone number column is removed. So the only thing that I'm a little bit worried about here is replacing states with integers. Okay. Statistical overview of the data. So we are doing sort of like a little summary, it's describe with pandas. And we sort of have this information already, because if we look in here, we can see that count length is normally distributed, and I'll scroll over. Actually, that's right. The easier thing is probably just to do this. So we can already see like information about the distribution and the mean from our little thing here. So you can see like number of voicemail messages. Most people have 0. That's very skewed. And that most other things tend to be normally distributed, except for total international calls, which is more, what would you guys call that? Logistic, maybe? I don't know. It's not normal without some sort of scaling. Okay, and then we've created some graphs, so that's good. And this is a Plotly graph. And we're looping through. And this might just be because we're so zoomed in, so it's wrapped. Yeah, so this is a pretty long line. I would probably have broken this up in the middle and just bumped it down over multiple lines. Again, that's just a style thing. I think PEP8 is like 60 characters or something, 63 in there is the recommended line length, so you can look at narrow code next to each other. Right skewed, everyone's saying, yes. And Prithviraj says right tailed, so that is, yeah, the tail's on the right. Martin says 79 actually. Thank you. Less than I want it to be. I want to have them big long lines. Positive skewed, yeah. I was more thinking the specific shape of the distribution. Kumar says it looks like Poisson. It does. Yeah, because there's nothing less than 0. So maybe Poisson. Yep. Okay. And then we have various layout information. This is fine. It looks perfectly good. It is interactive, which is nice. Churn percent is 14%, so 14% of people from, I guess, the sample that we're looking at, we don't know what the time span is, close their account, which seems like kind of a lot. I don't think let's see. I have closed one phone account ever, so that does seem like pretty high, but also I only have a mobile phone, so when I move, I just keep my mobile phone service provider. It's fine. And yeah, some agreement about it being Poisson. So we have more customers who stay than leave, so that's good. That's good for the business. And they're saying we have imbalanced class for target variable, which could lead to a predictive model, which are biased towards the majority, i.e. no churn. So if we just play the numbers game, we are more likely to say, hey, people don't leave, and we're going to predict that people don't leave, even though we want to minimize people leaving. Okay, and I'm going to zoom out just a tiny bit. There we go, just so the line wrapping isn't quite so weird. And we're going to look at churn distribution per state, and this is a graph that does this. This would be a good place to use a map because there is So these are ordered alphabetically, which is fine, but there's not a lot of information in the alphabetical order of the states. And there's a lot of information in the region of the states. So I am noticing that, for example, Minnesota, Wisconsin, New York tend to have more users, and California down here, and Indiana tend to have fewer users. Pennsylvania tends to have fewer users. So I would probably want to do a map with hotspot information. So where the color and the value, so like dark states, more people are likely to churn, lighter states, fewer people are likely to churn. So I think this is fine. It's really good for comparing sort of the number of customers that we have in each state in our telecom that we're running together. But it doesn't tell me a lot about the geographical distribution of churn, which I am more interested in, given that we have the geographic information. And then we're looking at features for customers that do and don't have churn. So we have another, and this looks fine. I'm assuming this is looking a little bit weird because we're just zoomed pretty far out. So this block of code, like the if-else's here are extremely weird. And again, that's a style thing, and I shouldn't be focusing on style thing. Oh, I see. It's, what's that called? List comprehension. Okay. Scroll back in. So it's, yeah, that looks pretty readable to me. So looking at this, we're looking at the distribution of features between churn and no churn. So I probably wouldn't just use color for this, and I probably definitely wouldn't use orange and blue. I don't know if any of you are color blind, but this definitely I think could be a little bit hard to read. And then we're using a slider. Don't love this. I'd probably use a tick box instead of a slider, just because a slider implies that there's a relationship between the things on the slider, right? It implies that as I'm going this way, as I'm going to the right, I'm increasing something. As I'm going to the left, I'm decreasing something. And what I'm increasing and decreasing is the index of the column, which feels a little bit weird to me. It's counter to my expectations of how a visualization is going to work. But it is nice. Okay, and just looking at this, so it looks like customers that have churn, and I also probably, because we are looking at distributions here, I'd probably use a distribution plot or a density plot instead of a count, because I want to see if there's a difference in these distributions, and I care less about the raw numbers. So I'd want to see, so it looks like this is a little bit more of a uniform distribution, the customers that have churn than the customers that don't have churn. So this suggests to me that customers who are leaving are more likely to call customer service more times than customers who don't leave. And I think that particular information would be easier to get if we were looking at sort of the shape of the density of the distribution instead of the raw counts. And that's, again, my preference. Same feedback. It also looks like maybe the sort of the center of the distribution is a little bit higher for customers who have churned, to make maybe a little... they maybe get charged more for international calls. So again, maybe there's this promotion where when you sign up, you get, I don't know, do y'all remember those like Sprint commercials, like 5 cents a minute or whatever it was? I don't remember the numbers. Like the like drop to pin. I don't know. I'm going way back in the data banks. Those of you who aren't from the US maybe never saw those commercials. That looks like the distributions may be a little bit different. Preacha says, what are you going to do instead? Box? Yeah, you could definitely use a box and whisker plot here. I tend to prefer density plots to box and whisker plots, because box and whisker plots can very easily hide a multimodal distribution. So if there's a binomial distribution of the data and there's a pretty big difference between those two groups within your subgroup, you want to know what that is and what's going on. And a box and whisker plot will just just sort of show you the center and the quartiles and then the outliers, which is less informative to me, especially in a situation like this. You could also do a rain cloud plot, which is a box and whisker plot, and then there's a dot plot underneath it. So that gives you information on the distribution as well. Yeah, looking through here, it looks like night calls doesn't seem to be pretty different. Evening charge might be a little bit different. Again, it's hard to see without looking at the distribution. So that's my main piece of feedback here. This looks pretty different. So this might be a particularly informative feature. So the amount that they are charged per day, it looks like customers that leave are getting charged a lot. So people are more likely to stay if they aren't getting charged as much, which makes sense. Okay, and then, so if you're going to talk about specific features, specific interesting plots individually, I would probably, so for a presentation, for example, I would probably say, I looked at a bunch of different things. Here are the things that were interesting. Plot, explanation, plot, explanation, plot, explanation. That would be my preference for getting this information. Huang says, what do we do next when we know the distribution of this column? We look at it. You can do statistical significance testing to see how robust the difference is, or is likely to be in other samples. So this is more for feature selection and potentially feature engineering. If you notice something like a bimodal distribution of a specific feature, there's probably something else going on there. So you might want to see if there are other features that you can use to generate a new feature that will describe that bimodal distribution and give you a better understanding of the data. Sip of coffee. Okay. Next we look at the box plots. Okay, that's good. Again, I talked about some reasons why you might not want to use box plots. Number of voicemail messages. So this looks like it might be pretty different. Like there's a lot of outliers with a lot of voicemail messages, but you'll see that the median for both is 0. And this is another place where a box plot is not that helpful because this is very skewed, and the box plot isn't really giving you that information. Lots of differences. So it looks like total daily minutes. Customers who leave tend to make more minutes worth of calls. If you are going to do box plots, personally, I like notched box plots. So they'll have a little notch here. And it's a really quick way to show statistical significance because in a notched box plot, you will have a statistically significant difference between your populations if the notches don't overlap. So it's really easy to see how big a difference is. Total daily calls doesn't seem to matter. Charge, it looks like that's probably the most different so far. Total international calls. So interesting. It looks like the bulk of the distribution is slightly different, but the median is right around the same place. Yeah. And again, I probably wouldn't give a stakeholder all of these graphs. I'd pick out the interesting ones and be like, here's the information that I learned from it. Because if you're a data scientist, your job is to look at the data, understand it. If you're building a product, build a product around it. And then you do sort of like the intellectual work of seeing patterns and figuring out, establishing which ones are spurious and are not, relevant to your problem and sort of noticing what are false positives. So my problem, and then we have the pairwise Pearson correlation. Okay, yeah, this is definitely not something I would hand to a stakeholder. This does feel like something that maybe a professor or a teacher has asked for, and I think that's fine, but probably not something I would again hand to somebody who is needing this data for something. And we're doing pairwise correlation, so I love correlation heat maps. I think they're a great way to do sort of feature, initial feature exploration. You can see that, of course, most features are correlated with themselves. Whether or not somebody has a voicemail plan and their number of voicemails is also very highly correlated with each other. That makes sense. And then for these things where it's the number and then the charge, we have these little bars, because if you do more, you'll get charged more. So there's no surprises really here. And then churn, so this is our target variable. It looks like the highest negative correlation is the voicemails, and then the highest, there are no positive correlations with any of these features, sorry. So blue is a negative correlation, red is a positive correlation, and the fact that there are no positive correlations might be due to the class imbalance. All right. And then there's just sort of a description of that. And we can identify and remove duplicate features according to their pairwise correlations with others. I think that's fine. So even collapsing this down into like a, so maybe only doing the number of minutes, or only doing the charge, or maybe even doing charge per minute as an average, might be more informative than having each of these separately, possibly. Huang says, Prithviraj says, how is it nominal variables are included in correlation? Remember that they were converted. So here, that's a really, really good question. Thank you. Here, state is being treated as an integer value, where 1 is Alabama, or Arkansas, whichever one it is. Let me see. We can see in this chart. 1 is Arkansas, 2 is Alabama, 3 is, oh wait, what's AK? I think AR is Arkansas. Alaska. Oh wait, there's AL, Alaska. Anyway, so we are treating state as if it were a number, and Virginia is somehow more than Washington. So that is not actually informative, and that's a really good thing to call out. Thank you. And Hoang says, when we have some features, it's very highly correlated, not with the target, so we will remove it or use it to create a new feature. So things that are highly correlated, so features that are highly correlated, the problem that you can run into there is called, oh my god, I'm blanking. Oh my god, what's it called? Oh my gosh, okay. Have some coffee. Amit says 0 is no correlation rather than negative. Yes, so the farther from 0 a correlation is, the stronger the relationship is. Positive means that as x increases, y increases. Negative means that as x increases, y decreases. Multicollinearity. Holy crap. Wow. So the problem with multicollinearity is if you have two features that are very predictive of each other, they will be down-weighted in some types of final models. So even if each feature individually is very informative because they tell you the same thing, they aren't as likely to be, the information that's in them isn't as likely to be used in the final model. And there's everybody telling me what it is after the lag finally caught up. Thank you guys. Jared says, I really hope they made one hot encoding with the categorical variables before putting them in decision tree models. Yes, definitely. Decision trees can take variables that are categorical variables as just like raw input, and we would want to do that. Yeah, thanks for calling that out. That is a very good piece of feedback for this person, so I would probably just remove state. Also, area code is another one that, actually, I got a question about that. I don't actually know. There we go. Show me the map. Yeah, okay. So I was wondering if there was sort of a geographic relationship with area code numbers, and it looks like there's not. So in California, we have 530, 442, 559, 209, so it's sort of all over the place in terms of numbers. And there's the 757. That's where my my phone area code is from, even though I live over here. So yes, I also probably wouldn't treat area code as a numeric variable in here because I don't think it is one. Prithviraj says, will multicollinearity affect logistic regression? Yes. Regression is very sensitive to multicollinearity. Ryan says, if you pass it into LGBM, it all goes away. Just define them as categorical in your data frame, and it uses the Fisher method, so you don't need one-hot encoding or anything. Very helpful. I know that in R, pretty much all of the cart methods will just take in a factor, but I am less familiar with doing regression and decision tree modeling in Python, because I think R is better for it in some cases. All right. And now we're doing clustering using a dendrogram. Okay, so this is for reducing dimensionality. You know what? I don't think we need to reduce dimensionality. We've got 12 features, 11 features? I think it's fine. There is some multicollinearity, which is not obviously not ideal, and I might want to reduce that, but I don't think we have too many features to work with at all. I probably wouldn't do dimensionality reduction until we had a couple hundred features, maybe more than 500, just personally, depending on the compute and the time constraints I had for the specific model. All right. Oh, sorry. Roland, you says autocorrelation. Oh, wait, no, that's time delay. Autocorrelation is from time series, usually is where you see it. No worries. It's, I don't know, someday when I have more free time and I'm not just going to conferences constantly, I'll sit down and figure out how to reduce the latency so we can have more of a back and forth. Or a snappier one, at least. Anyway, so first off, I probably wouldn't do dimensionality reduction. Kumar says, would you recommend dropping state and area code or keep them in one-hot encoded for linear regression? I would keep them. I probably would do one-hot encoding. And the reason that I would keep them is because, so remember, we're a telecom company. We want to target customers. If I want to do a mailer campaign, it's going to be cheaper for me to do that from one centralized location and be these are the 4 states where people are more likely to leave, so let's mail them things. So I think that this is important information for us to know for our business use case. All right. And we're doing hierarchical clustering with average linkage. Again, we're zoomed in pretty far. But even with that, these lines are super duper long. And that's a style thing. That's not the main focus. But I would prefer that the lines are less long. Scroll down to where we were. All right. Inverse correlation is 1 minus the absolute value of the correlation from our data frame. So this is actually positive inverse correlation. Because we're removing sign information from this. So I guess this would be more strength of correlation than purely inverse correlation. Amit says, can I have the days and time when Kaggle live streams on YouTube? So right now we do Wednesday at 9 a.m. And this is a test doing Friday at 9 a.m. Usually I do Friday at 4 p.m. But I will keep you guys updated. And I try to post on the YouTube social function, I guess. I haven't used it a whole bunch. I'll try to be better about it. Okay. Yeah, this feels a little bit unnecessary, and also this graph is kind of hard to read. So basically the idea is that it's like a cladogram or a genetic tree, so things that are closer to each other on branches have more of a correlation. So here we can see that the probably the most closely related to variables are voicemail plan and voicemail messages, which makes sense if we look at our correlation matrix up here. Scroll down here. I don't know that we needed this. That's my feedback here. And you can see that there's a pretty strong relationship between, this is also pretty hard to read. So total minutes, total daily minutes, and total daily charge, total international minutes, total international charge, total evening minutes, total blah, blah, blah. All of these are pretty much, very, very, very close to each other because they're extremely related, because one is a function of the other, presumably a linear function of the other. Ryan says, the best you can get with delays on Twitch and YouTube is about 5 to 8 seconds in low latency mode. Good to know. That's not too bad. I will find some switches to flick. Yeah. Okay, and then we're saving duplicate features for later use, and then presumably removing them, splitting the data set into feature vectors in the target variable. We didn't do anything with this. We just made a list. So first of all, I wouldn't do this by hand. I would do this using the output of the dendrogram programmatically if possible. So something like, if distance less than 0.01, add to list, or something like that. Typing column names by hand is almost always a bad idea. And then we don't do anything with it. We split our data frame into target and input variables. And then we normalize the data set, which isn't needed for some things. No, we are not normalizing. We are doing the z-score. So this doesn't change the distribution. It changes the center of the distribution. So this I would redo. This does not say what it says it does. Which is a really super duper common mistake. And I actually have a normalization data cleaning. There we go. And I have a pretty in-depth description in this particular notebook about the differences between z-score and normalizing. So they're different things. Very common confusion. I also had it at some point. Okay. Oh, so sorry. So the reason that you would do this is so that the scale of differences is the same between your different variables. So what this will do is it'll take pretty much everything, all of your distributions, center them around 0 and squish them so that they are more or less between -3 and +3. So each point is defined as the number of standard deviations it is from the mean, negative or positive. That's the whole thing. Ronnie says, normalize by hand. Haven't seen that in a bit. Yeah. I mean, I see that they understand the math of what they're doing, but I also probably wouldn't do this for... Okay, I wouldn't do this at this point. Okay, so they're saving this as normed. I wouldn't use normed for the decision trees because then you're doing additional modifications that you don't need to do. And we've gotten a very small way into this data set. We're like, we're maybe like 3/5 into it, 2/5 into it. And it is almost 10. Jer says it moves the standard deviation to 1 and the mean to 0, doesn't it? Yes, absolutely. So normalization, when I say normalization, what I mean is whatever the existing distribution is, I want that distribution to become normal. So like log scaling can sometimes normalize things. This is scaling, so it is making all of your features have sort of the same range and the same center of the distribution, but it doesn't change the shape of the distribution, if that makes sense. All right, and then PCA, to reduce the number of features. Again, I don't think we need feature reduction or dimension reduction in this data set. There is some multicollinearity. That is something to watch out for. I might do... I might drop features that are highly correlated just to avoid that, or I might change it into a composite feature that captures information from multiple features. But we just don't have enough features to do dimensionality reduction. I think we're good in this particular instance. All right, I'm gonna call it a day there before we get into the PCA and the principal components. So you get really good results, like above 90%, starting around like 10 features, and we only have like 10 features in our original data set, so I don't know that this gains you anything. Jer says, since they're using Python, why didn't they use standard scalar? I don't know. This strikes me as a very in-depth project that this person did for their own learning. And if you are doing things for your own learning, then I think that it makes a lot of sense to sit down and actually type out the equations as code so that you can understand what's going on in the equations, and that's fine. I would not do that if this were a professional setting and this was something I wanted to hand to my manager. I wouldn't do that. I also just like to reuse other people's code as much as possible because I am efficient. Anilon, in such kind of problem or statistical modeling, I tend not to use anything that deals with principal components, since this will make the model quite difficult to explain. Yeah, that's also a really good point. I like to explain principal components as sort of like shining a light down through a tree. So like instead of having the tree and the leaves in their position in space, you instead have the shadow of the tree on the ground, which can be helpful if you need to do things that are flat, I guess. If you need to trace a tree, it's easier to trace the shadow on the ground than it is to trace the tree in the air. But you can't look at the shadow and be like, this leaf did this leaf did this, after the fact, when once all you have is the shadow. I don't know if this is making sense. It's a little bit early for this type of math. But the sort of general point that I'm getting at there, that Yilun brought up that I'm just expanding on, is that if you're doing any sort of dimensionality reduction, you have less information at the end of the day. In terms of explainability and storytelling, and if you say, hey, people in Arkansas are canceling their plans at twice the national rate, we should focus on Arkansas, that's very helpful. If you say, hey, in the first principal component, which accounts for 40% of the variance, we see, that people... I mean, you can't get information back out of that, if that makes sense. So, good point. Kumar says, which decompensation or feature reduction methods would be recommended as a general rule of thumb? The first thing I always do is go through and remove features by hand if there's going to be leakage from them, which obviously you can't do if you have like 80,000 features, but as much as possible, I do like a first pass with my eyeballs. And then, I mean, there's nothing wrong with PCEA, but it does reduce the amount of explainability that you have. You can look and see what features are weighted and how much within the first principal component or the second principal component or whatever, but it's less easy to interpret. So, all right, it is past 10. I usually only stream for an hour, so I am going to wrap this up. It seems like this is a pretty good time for people. I have a standing appointment on Friday mornings that was canceled this week, so I may see if I can jigger that around, because this does seem like a good time for folks. Yeah. And then Hasha says, how does the notebook deal with the imbalanced target variable? I don't actually know. We didn't get that far. My assumption is oversampling or undersampling. Let's look in the table of contents. It's not there. It's not there in the table of contents. So let's see, over. So yeah. Okay, they import it and then never use it, as far as I can tell. Oh, here it is. It's right in here. Synthetic minority. I don't know why I couldn't type good. So synthetic minority oversampling technique is one. Class weights and the loss function. So there are other things. Oh wow, a lot of people said a lot of things. I always use feature importance that gives you random forest. I always use the feature importance that gives you random forest. Oh, like the feature importance you get out of random forest. Yeah, that's super helpful. I really like I like tree-based methods. A lot of my dissertation was about tree-based methods, so it's nice for me. For logistic regression, I usually do deviance tests and check AIC and log likelihood. You can also do what's it called? Stepwise regression, where you add additional features. Sometimes statisticians will yell at you about that because you can tap into sort of spurious features, but if you're doing it in a principled way and you have a reason for adding additional features and in the direction and in the order that you do, I personally think it's fine. I've done it. That's just me. I love the explanation of PCA. Oh, thank you. Section 4.3, sampling. Yep, they use weighting. Amit says, is there any website we can know what is going to be doing next week, both for Wednesday and Friday? Yeah, we don't really have a centralized place for that. And I also usually decide like the day before. Yeah, I can try to post on YouTube every week when and what's happening. So next Friday, I won't be doing live streaming because I'll be in Cleveland for PyCon. I'm giving a talk. It should be really good. But I will try and record something and then have it premiere so you guys can watch it together if you want. And I'll try and have that at 9 a.m. Pacific since this time does seem to be good. And that might be a talk that I gave earlier about how to make data sets successful. Step AIC, Elon says, I was just about to yell at you, but usually backward selection is better than forward selection. So usually in the places where I've used forward selection, it has been specifically for experimental data that I've collected, and I have an a priori reason to believe that feature 1 is the most important, feature 2 is the most important, and I don't know how important feature 3 is. And that's when I use stepwise regression. But yeah, if you have statisticians on your team, maybe don't do that. Headshot M4A1 says, how would you select the model to be used in this case? Trying multiple models is my way. Yeah, model comparison. You just want to watch out for multiple comparisons. Pravaj says, quasi-separation is another issue I have encountered. No clue how to tackle it. I don't know that I'm familiar with quasi-separation. That's something for me to look up. Which I will do soon, because I do have a meeting that I need to get to in the not too distant future, so I need to head out for that. Thank you, everybody, for joining. I hope this was informative. I just sort of talked a lot. We didn't get very far in the code review, but there's a lot in this notebook. I think overall, it seems perfectly fine. My biggest sort of feedback is it's just super audience-based. If this is something you were going to hand to a manager, I might do like 4 plots. Here's the features that I found were really important. 2 models. Here's model 1. Here's the predictions of model 1. Model 2. Here's model 2. Here's the predictions of model 2. Here's the benefits and drawbacks of each model. Which one of these would we want to use to decide which areas to target? And then if we use this model, here's our proposed action plan. If we use this model, here's our proposed action plan. And here's sort of like how uncertain I am. And that's sort of what I'd put in a presentation to the manager. All right. Thanks, everybody, for joining, and I will see you next Wednesday. And I don't know what paper we're going to be reading yet, so I will do a poll for that. I've had a couple of suggestions, and I don't want to just sort of like unilaterally choose since you guys are going to be watching, hopefully. So I will do a YouTube poll, and I'll do a Twitter poll, and we'll see what paper we do. And I will see you guys on Wednesday. Bye.